I am showing a, schematic, circuit schematics. So someone explains this, what is a circuit, how does this function? Okay, we are done with the meeting, and then we'll all wind up. So next 2 minutes, who wants to explain part of the circuit and functionalities of the circuit? Who wants to go first? Most of you are all biomedical engineers. This is actually very basic for mechanical engineers, very basic for electronics engineers, very basic for electrical engineer, mechatronics, combinations of those engineers is very, very basic. But you're all biomedical engineers. So perhaps like me, you have spent most of your time understanding the human body, right? Not necessarily the electronics side, right? Most of you have interocepted, not necessarily exterocepted, right? So I have shown a circuit. Of course, there is a motor, there is a battery, then there are a couple of elements. We have a photoresistor, we have a transistor, and there is also a resistor. Okay, so the motor is going to run, and this is running. The power is coming from the battery. The battery is what makes the motor run, and there is we have some couple of connections here. Can anyone explain? How does this is also small part of engineering project. Most of you are supposed to do an engineering project. Very, very, very simple system. One of the simplest systems. Okay, and due to various reasons, know about students here that is who are sitting in this meeting, but at least students who are listening eventually, right? They typically go buy this kit or a project, ready-made project, right? And they go submit it, and then they don't get a chance to learn. And then there are students who the circuit is given. For example, I give you the schematic and quickly take it and connect it, you know, using just wires and all the components. You can source them, and then, or you could do it in a breadboard, okay, or you could get a a, a a breadboard, various sorts. You could you could take a PCB. You could do all sorts of those things, right? This exact circuit you would easily replicate it. Then all of a sudden the circuit is not working. You know what to do. Right. Typically, whenever someone explains you, right, how to make, you know, how to control a motor speed with a potentiometer, for example. So they give you the circuit, and you're always like, learn what this circuit does. But the moment you perturb that circuit, you change any parameter of the resistor. What transistor do I use? Okay, what should be the battery power? And so there are a couple of questions like this. There is also a diode there. All of a sudden, at least from the silence that I am hearing, somewhat poetic, right? The silence that I am hearing suggests that, right? So the objective of this meeting is to get some clarity on how this thing is working. Due to time constraints, due to cost constraints, I couldn't quickly source any of the parts. So I'm going to use a virtual simulator, but we'll also try to put that in a sound footing, realistic footing. We'll discuss what some of these numbers should be and all of that. But first, we have to understand the circuit quickly. Okay, so there is a 1 kilo ohm resistor. Okay, so what? So that's a part here, but what does it do? The question clear. Can anyone explain how the circuit works? This is going to be a master class on how the circuit works. I already gave you a disclaimer. So the amount of time I have spent with circuits like this is not a lot because I have spent time with some other circuits. But I do have the experience and I do have the background, and you learn some skills that you could transfer from one field to another field. So at least today I'm in a position to try to explain what's going on in the circuit. Okay. So that's the objective. Are we ready for it? That is, if you put something in the circuit, by the end of the meeting, you need to know why it is there at the first place, so that you could go change it, modify it, synthesize it, create new designs and all that. Subjective clear is a very important objective. And from the sound of silence, right? Of silence, I am checking the chat. So my audio is connected. Yeah, from the sound of silence. So my ears are working, right? I am also kind of aware of that. Seems to be like, hey, are you all ready at least?
Yes, sir.
So let's make this sad state of affairs into a happy state of affairs. Hey, this is Mechatronics 101. Engineering students outside of biomedical engineering learn this on class day 1. Okay. But as I said, our students have spent time elsewhere. So this has to be addressed differently. Okay, great. Let me share. Sorry. So before you and I share that, I have 2 questions. One second. Kirtika is here. She is supposed to present. Where is Kirtika? Kirtika did not show up. Was offered help and now the help is not over here. So, we'll do that. And a quick question to Arjita. Hey, I found a recording of the your what is this? Your webinar on uh, stroke rehabilitation. Is it okay to put it publicly? That is on YouTube channel. Yeah. So I'm going to use this TinkerCAD for today. Okay. TinkerCAD. I did change the slide, but this is not. Haven't changed. Okay. So Arjita has given me a yes, sure. Okay. Great. Yeah, I have. Hey, this is TinkerCAD. As I said, we run short of time and resources, and this is a quick way to test your circuit, right? Virtually test it, before buying the components, putting them together, and then you have to worry about how have you connected the circuit properly, right? So those things shouldn't come at the first stage of designing a circuit, and specifically at our current stage of understanding a circuit. So what do we need? We need a DC motor. This runs with DC power that is not going to oscillate. So let's also pull up a battery. So the battery is pointed this way, is it? Yeah, fine. Now, and I suppose the motor. Yeah, I'm also new to TinkerCAD. Okay, so I learned it actually today morning because the student who said will make the presentation somehow hasn't shown up for the meeting. So I will have to be figured out. So it's going to be on me. So I learned this today morning. So I'm not all that fluent with it. But now, okay. So the motor, if you say it run, it wouldn't run. I mean, in the sense that it needs power to run, right? So I suppose the positive goes here to the positive. Okay. Hey, is there a way to change this, man? Yeah, there is a way to change it. Flip it, flip it, flip it, flip. Pull it out to this side. Okay, now this is better. It's also, So I suppose positive goes to positive. And if we close the circuit, we have the motor can draw power from this and should technically run. Okay. So this is a virtual circuit So you don't have to worry about whether you will damage the battery or the circuit, okay, or you are understanding any of that. So we can go ahead and do that experiment right now. Let's start. A motor is running with 17,568 RPM. So motor is running right now. So I suppose this is also clear, right? So the number read 17568. So you could all go to TinkerCAD and sign in with your Gmail, and then you could try this as I am doing. Fine. So this part is to everyone, I suppose. It's also actually a conceptually very hard part, like this power is getting transformed. But anyway, so the battery is like making this mode change, right? First thing is, hey, this is rotating at 17568 RPM. We want some control. So we need some ability to change the current flowing in here. Okay. So I'm going to remove that and I'm going to pull a photoresistor. Okay, what does a photoresistor do? Easier question that most of you know. So I suppose there is no positive negative for a photoresistor. So we will connect it. Circuit, circuit is terminal 1. Circuit is closed. So what will this do? How many revolutions per minute? RPM. The moment I put a photoresistor, all of a sudden it became 6 RPM. Why? It was some 17,000, so on, so something. Okay, great. So now two things. Now I brought in photoresistor because we wanted some control over changing the voltage or current in the circuit. Photoresistor, so now they interact with light. So we get a control. So if we were to use light, I suppose, notice if we click the photoresistor, there is a knob which tells you, oh, how much light is falling on that uh, photoresistor. You can simulate that. If you let a lot of light fall on it, if the motor is running faster. So there are resistance changes. And to recognize, notice, by default, the photoresistor has a resistance. So the moment you introduce in the circuit, now lesser current flow, right? So because of that, the motor is running slowly, 6 RPM. But of course, the reason we introduce this is we can control things. Right now, this is let's get 1008, 1003, 1041, 1003, 1048. Why is this not moving from? I don't seem to have able to get 1008. I'm getting 1003. Okay, or I am getting 1041. Okay. Quickly notice I'm not able to control the revolution even here the way that I want. Like I'm not going to even able to get the number that I want. That are like things are jumping, but that is understandable. Okay, somehow things are still digital. Fine, let's stop the simulation. At this stage, I expect curiosity and questions as a reflections of that. I will push you. I'll give you some directions, some control. I will also tell you the problem. How which photoresistor we don't have really control over the current that is flowing there, right? Can we control? Okay, we have some control, but still, you know, it's not. This is not the best we could do. Can anyone tell me couple of ways we can improve our control here? We want to control this motor. Couple of ways that we can get more control of this. Right now, this photoresistor, this resistance change perhaps is non-linear. Is there a way to look at it? Let's see. Okay. Oh, it's not running, right? So 6, 200, 500. If we move halfway, this is 1000. If we move full way, this is 2000. Okay, there appears to be some sort of linear control, but this alone will create a lot of problems in a realistic circuit. Okay. One example being, we want to be able to control the current through the motor. The moment you have a resistor, right? So the speed of the motor now depends on the current. We don't have very good control over the current. Okay. You could think about it this way. So now, what are some ways we can think of improving this? Offset pulse width modulation. Motor driver can also be used. So Nafisa said you could do a offset pulse width modulation. So I'm going to read that as you could use a transistor, and then you could consider pulse width modulation on top of that. See, the whole point of this discussion is I already showed you a circuit, right? Why should we arrive at it? Why should we consider a MOSFET, or why should we consider a pulse width modulation? That is the objective of this discussion, right? Because that is a gap that is like typically missing, right? Motor driver can also be used. Hey, what is this motor driver? So many of you, couple of you are suggesting a motor driver. That seems to be some sort of a black box now that will give you like control to change the RPM, I suppose. So I suppose this say someone names L293T. I suppose it's sort of a, at least you are saying it as a black box. Is that roughly correct? It will give you. So now I'm showing you something. If you at least send current, it's going to rotate motor like that. There is an acute component that will give you that control, is it? That's what you are arriving at. Did I hear that correctly? Regarding motor drivers, could control with Arduino easily. See, of course, we'll get there. Again, if you treat them as black box, the ability to perturb and around and modify and design is drastically reduced. You already know the subject. You know how that, at least some idea on how the black box works. Your objective is something different. Case yes, but first to understand uh, where that control is coming from. Okay. Um, let's introduce a transistor. Okay. So just one question. Yeah. So at this stage, let's say the biggest problem that we are facing, right, is that our ability to control the current in the motor is very, very less through this photoresistor. Okay. So for that reason, we'll try to decouple the photoresistor from the transistor, I mean from the motor. So we'll bring in transistor. These are suggested MOSFET, but I am going to use a BJT for this case. Okay. So now how do we connect things up? So I already showed you the connection. So I'm just going to recreate. In the process, we'll also need a resistor. This is slightly preferred unless is it, yeah, okay, I can get it. Give that connection cluttering. Okay, so now let's MOSFET can be used. The transistor can be used. The BJT can be used. Okay, either can be used. First, I'm going to go ahead with the JT. Okay, this is the NPN transistor BJT. So this has a collector, base, emitter. Okay, and I'm going to connect it in a specific way. So let's connect this. See, sort of now I'm trying to control the phase of the transistor. Okay, very briefly. Can control the phase using the current that flows through it. I need control over how that how much current I allow through the phase. That depends on the resistance in the rest of the circuit. So I'm going to explain this again. So that is one circuit that I let's also change the color to black. Okay. Next thing is okay. Now I'm sort of as you said, I am going to use BJT as a switch, but I didn't really describe it. We'll get there. First thing is now, but let's uh, find a means to let current flow through this circuit. Okay. So let's close this. After this, okay. So notice at least the motor switches is a closed circuit in the motor except for this bit, right? Make the let's make this connection. So what we noticed we couldn't really control the current in the motor directly using the photoresistor. So now we are rather going to control current in the motor. That is, we are going to use a transistor to turn on and off to behave as a switch. So now the circuit is 9 volts connected to the motor. Okay. And then that switch is turned on and off by what is there at the peak. Very, very brief. Okay. Now, and can anyone explain what is going on here with the photoresistor and the diode? Number one. And what is going on with the transistor? For example, now my question is, hey, how do I choose this resistor value? Right? Which resistor do I pick? Okay. In fact, that also includes perhaps which photoresistor do I use here? Okay. But yeah, how do I choose this resistance value? And what are some of the parameters of this transistor that are important? To answer that, we need to know what is going on in the circuit. Can anyone put that into words? Transistor acts as a switch. Correct. The question is how are we controlling the switch? And can also someone clearly say what current flow circuit through the motor? Through the motor, current is flowing through a closed circuit. Which loop is that? Can anyone? Let me kind of simplifying that. I already notice this negative terminal I am fitting is down, so that is in black. This is also in black. Let me differentiate two functionally different components here. Okay, so this is in green. Let's change that for some other color. Let's change this to red. Let's do pulse. Okay. This is also purple. So there isn't sufficient contrast, so I'm changing this to orange. Okay. So now at least two closed loop here in the circuit. There are two closed loops. There is a green loop with the ground, and there is an orange loop with the ground. Do you see that? Also make this orange for the time being. Let's make this green for the time being. Whether current is flowing, whether electrons are moving, that's a different question. For now, there are at least two distinct paths for current to flow. I suppose the moment at least when I color code it, it becomes fairly evident, right? And of course, from 0 to 0, current is not going to flow. Notice the moment I color coded it, I found something odd. And flow from positive to negative. There are two loops through which current can flow. You could see that, all of you. And if this loop is not that clear, it goes, has a stop at the base, then it gets back. Okay, so no, we'll come to pulse width modulation in a moment. Of course, we'll finish with a pulse width modulation in our Arduino circuit. But before we understand, that Arduino circuit will also have some kind of a transistor or that uh, motor driver. Okay, to understand what is going on there, at least it helps to first understand the simplest circuit. Great. So probably the orange loop current flows, the green loop maintains pulse width modulation. Actually, in this case, in both the loops, current is flowing. There are two parallel loops. Okay. The green loop, there is a resistor and a resistor in series. Voltage division happening except for any leakage through the base. So because these two resistors are in series, okay, almost this flip, this we have this is a voltage divider circuit. We can control the voltage here at the base by changing the one of the resistances. So that tells us this transistor will have a specific rating, right? Okay, what is the voltage here? We'll turn on the switch. Okay. So based on that, now we can quickly choose these two resistors. The order of voltage that we are expecting here and the current that we are expecting there. Based on that, we can quickly make a call on how to choose these two resistors. Okay. So the green loop is just a voltage divider, controllable voltage divider. In fact, this is indeed a potentiometer, right? You have control over where you take the voltage, measure the voltage, right? So this is actually green loop is just a, let's say, a potentiometer. Okay. So first terminal, second terminal, and the third terminal. Could see it as a potentiometer, or you could also see that as a voltage divider. So now we have ability to control voltage at the base and specifically in turn the current at the base. So we have the ability to turn on and off the switch. When the transistor is turned on, it will allow flow of current from collector to emitter. So if I start with the positive terminal, track the orange. Okay. Now current flows here, positive terminal, current flows through the negative terminal, current comes here to the collector. If switch is on, it can go to the emitter and then complete the loop at the negative terminal. Yeah, some of you said orange loop has the load of the circuit and the green loop has minimal current, carries the base current from N transistor. Yeah, that's correct, Harish. Yeah, that's what I was trying to say. The green loop controls the motor, on the orange loop controls the transistor. Okay, so question is this: green loop controls the current, controls the motor, and the orange loop controls the no. Green loop controls the transistor. It turns on and off the transistor based on what the current here is. Transistor will turn on and off. Okay, so the green loop, okay, turns on and off the orange loop, and the current through the motor again depends on what the what this transistor characteristics are. But this is from 9 volt, right? Current through the motor. Got it? There is a subtle difference. The green loop controls the motor. Green loop is turning on and off the motor loop. Green loop is controlling the transistor by controlling the base. It is turning on and off the by controlling the transistor. It's turning on and off the orange loop, the motor loop. The current can flow in the motor loop. The green loop decides. Green loop along with the transistor. Fine. Clear? Got it? Yeah, Harish gave that explanation. So now you have this. Hey, this motor turning on and off, motor electromagnetic induction, this itself can sometimes, create currents, right? There electric field in a magnet, a change can induce current. So this motor, while it's turning on and off, can at least temporarily behave like a power source. And typically, you don't want any of the power sources to affect the transistor or any part of your circuit. So you make sure if there is any, while turning on and off, while changing the motor speed and all that, it doesn't affect the rest of the circuit. The way that you do it by having a control over the direction of current flow here. So I'm putting a diode. Okay. So here, based on the symbol, it can flow from top to bottom. Okay. So current can flow to the thought of a circuit protector. So let's take the red, something to name for that is flywheel diode. Okay. That runs a couple of other names. So let's momentarily delete that. But the motor is turning on and off. Of course, I removed the crucial thing, right? So let's momentarily delete this. Okay. Motor is turning on and off in that process. So notice I don't have the power source, but that shouldn't affect this transistor or any part of the circuit. In that case, current will flow this way back into the motor. Then why wouldn't but will the motor work when you want it to work, right? That is there a path through the collector emitter, route? So let's highlight that. Current is coming from positive. Okay, cannot take this path because this is in the reverse configuration, right? So the current can only enter the motor and go through the orange. So from positive to negative, the orange loop, current cannot enter the diode, this red loop. But if any current gets, momentarily gets generated here during turning on and off the motor, can, this is a diode, in the forward bias, this also has like very low resistance. So this can easily flow back into the motor and time this dissipate. So that you're trying to save the rest of the circuit with the that sort of a feedback loop. Okay, come to that part. Yeah, diode prevents backflow of current. If you could see, okay, which way flow is happening, it prevents backflow. That is fine. Current can flow back into the motor, no issue. Okay, but typically you don't want the here, at least in this case, the transistor to be affected. So this is the initial circuit that I showed you, and this is how this circuit works. Now let's also that. Okay, so if we have to have some contrast. So now does this circuit, does it make sense? One battery, one motor, turning, we got the ability to turn and off, on and off the switch, and so now current can flow through this. Let's see again. Let's simulate this. Motor 0 RPM, connections are fine, I suppose. Yeah, the moment we turn on the circuit, the motor is running. Okay, doesn't account for many realistic things. That is noticed. The motor RPM is like at most close to its max and all that. So this is the direct 9 volt is directly connected to the motor and it's showing that result. And what you got is the ability to turn and off the circuit. Now the circuit is off, 0 RPM. Let's say, is there a way to zoom this? Hey, there is a way to zoom this. I didn't know. Okay. Now you got a way to turn and off the circuit. Okay. Now 0 RPM, circuit is off, motor circuit is off. I turned on the circuit. Turn on, turn off, turn on, turn off, turn on, turn off. Let's see. Okay, I'm not able to do that. Very, yeah, okay, I'm able to literally do it. Is to a make believe extent that I'm turning and off that motor is like I'm controlling the speed of the motor. If you take the average motor, it's between 0 and 17,500. So if I do this sufficiently fast, the average is roughly, the average RPM. Does anyone know what I am trying to do? What I was trying to do? The name for what I just did. So I just did what is called pulse width modulation. On, off, on, off. So now the question is, what percentage it is off? This goes by the name duty cycle. And of course, notice already my forearm is slightly paining. I cannot do this in appropriate time scales. So this is why try to do is you try to control the base of the circuit using a Arduino where you can easily specify the duty cycle. There are a couple of ways to do that. You can notice I do have a potentiometer setup here. Okay, the green loop is a potentiometer setup. or if you put a potentiometer, you'll have to slightly modify that. But the idea is you can take the potentiometer output, okay, and then uh, map it to what extent you want to turn on and off the circuit. The beauty is, so now it's a voltage is always, for example, in this case, it says 9 volts. Right? The voltage that is across the motor is always 9, okay, barring some minor changes happening across the transistor, okay. So if you control the duty cycle, let's also look at it. If we say it like in words, doesn't reach out, so that sharp. Yeah, now you can use a microcontroller. You can use a Arduino to do this manual moving. Instead of that, you can program it to turn on and off. Okay, so you can design it so that the circuit is 50% on, 50% off. So 50% on, the voltage is always at the maximum 5 volt or 9 volt, the power source, or how you feed it. Okay, so the voltage is now through the motor is constant. Only that the power is changed. Okay, that is the extent to which it remains on is changed. So, for example, the 75% will run faster compared to 25%, and the 25%, because it is on for the least number of time, it will run slower compared to 50% duty cycle. And where is this duty cycle 0 to 100%? This ability to control the speed of the motor. Most of you are saying pulse width modulation, pulse width modulation. Now, how do I do this? The Arduino would really do this. Okay. So the Arduino will easily let you do pulse width modulation. One comment is it can be programmed with Arduino. Arduino has very limited pins which allow pulse width modulation. So what do you mean by that? Can you be more specific on that? I put up some agenda, right? So the need for LDR, the need for transistor, the need for photodiode. Okay, this is fairly simple. Okay, now we got to the pulse width modulation. Okay, you can turn on and off that better. Okay, yeah, we'll discuss some important numbers here, and then a few other. Arduino is not, that is, at least the way how you use Arduino now depends. Okay, now we have to allocate uh, another time for that. Okay, so fine. Is Arduino here? Okay, you can pick an Arduino, and if you also use a breadboard, now we can give this a better shape and discuss pulse width modulation through this. But even before, we'll have to do that separately. Okay, not today, based on the time that we have. We do have some questions. Of course, we want to upgrade to Arduino. Okay, that is the objective. Arduino or something that gives you the ability to do pulse width modulation. That is somehow that diode got okay, and that went away. Fine. Can be programmed with Arduino, but Arduino has very limited pins which allow pulse width modulation. For example, Arduino Nano, there are only 4 to 5 pins which allow PWM pins. So if you want to use it to multiple motors, it is difficult to use Arduino for that. Yeah, okay. So now the question is, the first, okay, now if you have multiple motors, what happen? Okay. Let the multiple motors in parallel. Okay. So now I have one motor circuit. Let's say one motor loop. You have multiple motor loops, right? In parallel. So the first question is there sufficient power through the battery to feed the motor, right? So the battery volt ampere rating is typically given. Okay. The transistor, some of the currents here, collector emitter current, and then uh, the base thresholds and things like that are also given. For the motor, in the voltage and ampere rating is given. Actually, the voltage here, if you don't really modify the power source voltage, if you don't divide it, you choose a power source that matches the motor's voltage. There is sufficient current here to feed the motors that you plug in. Okay, that is one thing you want to make sure. So, for example, if this is, you know, this 9 is slightly, let's say 5 volt. Okay, let's pull it out of the screen. Let's say 5 volt. Let's say this is 1.5 amps battery. Motor is 5 volt, and let's say this is 300 milliamps. Okay, so 5 times 3 is 1.5, right? So you can max run 5 motors, but there are efficiency issues, so at least you can max run, let's say, 4 motors. Okay, max is 5. If you consider efficiency issues, things will be better. So notice this BJT here is current control. To use a MOSFET, that would be voltage control. Whether the circuit turns on and off, you want to use voltage to control it or current to control it. That determines. In this case, notice your source is a voltage. So I started out with I can control the voltage here. I put a voltage divider and I can control the current there. So I used BJT. You could also do this with a MOSFET. Okay, point number one. So now I'm getting a couple of comments. For one motor, it is enough. For 4 motors, we can use motor drive along with it. Great. See, at this, in fact, I fortunately found some time to at least help you see this circuit so that, hey, what do we change? So how do I control the base there? Pulse width modulation, right? So now some of these things I at least wanted to get you started. This is bare minimal circuit where further modification. Okay. In fact, I really didn't find time for doing that. Okay. But now that we have done with this, so obvious question seems to be, get a Arduino board. Let's do a pulse width modulation. And is it a motor driver? What is a motor drive? Is there a motor drive in TinkerCAD? It's a rich motor drive. L293D. Some Arish mentioned L293D. This is there. So, and I'm not sure if I would be able to find that time. Okay, so my schedule is very tight, but can anyone use an Arduino to pulse width modulation and Pam show how to use the drive here and how a drive might simplify multiple motors? Is there anyone who wants to volunteer for that? Not necessarily TinkerCAD, could either virtual software. I chose this TinkerCAD was like at least They gave me access. I could make this circuit. Okay. Fine. Okay. So now Arjita is volunteering. Let's just have some balance. Isha, would you be able to find any time at all for this? Isha, because you are like from the beginning, you were saying motor drive, motor drive. Will you be able to find some time on this? And so I also made good use of the expertise of Chat GPT. Okay. Sometimes the expertise is very surprising. Okay. But you also need to know uh, also need to there is a knack of using Chat GPT, but because I was running short of time, Chat GPT really did help me out with this. So okay, so next week, Jitosh, at least first virtually show this. Need three things here. Click on Arduino, pulse width modulation, motor track. So let's do that. And if needed, if you're stuck or something like that, Isha is volunteering. Okay, I'll also try to find some. But quickly, those who showed up here, do you make at least? Do you start seeing? How do I this? That circuit went away somewhere. WhatsApp image. Yeah. Okay. Now you learn something. Silence. Do you start seeing? Typically you're reading about thoughts of this. Hey, what is this? What is a transistor and all that? There are like hundreds and hundreds of equations here. But the moment this shows up something like that, all of a sudden the meaning is lost. When the parts are assembled together, the meaning is lost because most evidently seen in the simplest forms, which is what I try to bring out today. Idea is not too complicated, idea is to simplify it. But did it help? Do you start seeing reading this circuit? I didn't. I was hearing it says and there was a sound of silence. So I suppose I did hear few things, but is there at least a better picture right now? It's highly inefficient. Let's do a poll. Great. So most of you had a better picture, and right. So what is the basic working of a motor drive? Because Arjita is asking that stage, me show what I would do. This is my whatever questions you had in mind. I kind of already uh, I asked the Chat GPT. So of course we are discussing control, closed loop control. Right now things are in open loop, right? Uh, but fine. So I'm purposely making the question complicated for Chat GPT. As much as I try to make things easy for students, I try to make questions or things complicated for GPT because it somehow, snip the information that I am trying to communicate. What and how do I use a motor drive? And is it good for, yeah, multiple motor setup? Okay. Question. Hey, this is essential when you are scrolling up on adding multiple motors. Oh, the circuit, they have made a black box of that circuit. Power transistors, flyback protection diode, sometimes logic for direction control. Okay. And then see at this stage, Arjita, quick answer. They have packaged the circuit that we saw. It's a very quick answer. Go probe further. So instead of potentiometer Arduino NPN transistor motor, do potentiometer Arduino motor drive motor. And of course, the question, there is one more question here, even an open loop. Do I want to control all the motors similarly, or do I want control over the different motors, right? First, let's control all the multiple motors similarly, same speed. Then we'll worry about varying speed, okay? Again, so one important, again, takeaway is not simple, add one layer of detail. Okay, so your first task is to make it multiple motors, and then the second task is to control multiple motors differently. Okay, so add one layer of complication, and of course we'll do that. We are kind of close to schedule time, so most of you voted, at least those who voted, better picture of the circuit, yes. And next week we'll look at the simulation, and by the time I'll also try to source the components. I don't know where the shop and all that. See, all the experiment I told you, right? So exceptions, all the exceptions, name exception, I try to do it, right? So, but we'll do it, okay? So hopefully in 3 weeks at least we can get biomedical engineers will start controlling a motor in a way, and we also understand what is going on, okay? Not just like we are reusing what is given, but we start synthesizing what we need, right? So Arjita, my suggestion again is when you're testing out, try simulation. When your simulation works, go to components. There are real world issues with components. First, make sure your circuit, your in principle things are good. The resistor is like now you smell something or the resistor is burning, right? Then you'll worry about the problem. So don't mix problems together. So one layer of complexity at a time. So one step at a time. Okay. Okay, great. Let's stop here. Have a good one. Take care. And so current affairs. Yeah, this is current affairs. What is going on in the group? Current